If you look on the back of your cheat sheet, there's a section called Precipitation Reactions. You'll notice that my lectures go out of order in regard to the order in which they're listed. Remember, I listed them in that order for when you classify. Whenever you're given an unknown reaction, always check if it's redox first. You received a new reference sheet that looks like this. You will definitely need that in front of you for today. You don't have to memorize anything on this sheet. It will be given to you on the test. You just need to know how to use it. Y'all remember this? All right, when we first started this year or this semester in reactions, I showed you a precipitation reaction where I mixed a couple things together and it changed colors and got really hot and it bubbled and it smoked, and then the poop monster showed himself. This piece right here is a new solid that wasn't there when that reaction started. And any new solid that forms during a reaction is called a precipitate. So there's your first new vocab word. A precipitate is a new solid that forms in a reaction. We've got a symbol while we're writing actual reactions to show somebody looking at our chemistry which product is the precipitate. Because in a precipitation reaction, just like my poop monster friend here, one of the products will be a new solid, the precipitate, and one will be something that is in liquid form. But this precipitate is going to be represented by this symbol. It's an S in parentheses, and it simply means solid. All right, so it makes sense that it would be an S. But a fancier way to describe this solid is insoluble, unable to be dissolved. When the reaction's over, he's sitting there in a solid chunk, not a dissolved liquid appearance. So certainly one of the vocab things you want to start off with today before I show you these precipitation reactions is that there will be a precipitate, which is very simply the solid that is one of the products will be labeled with this S to show that he's solid, which means that he's insoluble. He wasn't dissolved into a solution. But there's two products. That's one of them. One of the products that we're about to predict will be labeled with the S. The other one will be labeled with something different. AQ means soluble. It can dissolve and will appear to be a liquid. I explained that each type of reaction has its own little thing. Neutralization's little thing was an ion swap followed by salt and water. A precipitation's thing is still going to be an ion swap. We're still going to do that exact thing where we switch the first part of each compound. But we also have to label one of them with an S and one of them with an AQ. Here's the most common misconception that your brain makes if you don't study. When the test comes along, instead of thinking that S means solid, your brain will think that S means soluble. And then you miss a bunch of questions. So you've got to get that straight right now so that you don't crisscross these because they're polar opposites of each other. So you want to be careful. One other thing. By definition, a precipitation reaction has to have a precipitate. All right, it's kind of in the name. In other words, in order for this new type of reaction to take place, we have to form a solid. That has to happen. If, when we predict our products in a moment, both of them appear to be aqueous, if we have two aqueous products instead of one of them being solid, then no reaction will form. Listen to me say that one more time, and it's written on your cheat sheet. But listen again. There's going to be two products. One of them needs to be solid, S. The other one needs to be aqueous, AQ. If when we're doing these predictions, both of them are AQ, then no reaction will take place. Understand that just because you mix two things together doesn't mean a reaction will take place. I've used this example before, but this ring is made of silver. And if I drop it in water, that would be Ag plus H2O. Looks chemical if I write it down, Ag plus H2O. But what happens when you mix Ag with H2O? Nothing. It sinks. I get a wet ring. Just because you mix two things together doesn't mean something has to happen. So with this new stuff in mind, let's apply it. Write down this reaction in your notes. Don't write down the question marks. Just leave yourself some space. Here's our first example for you at home. Go ahead and pause the video and write it. What type of reaction is this? Or here, let's classify it the right way. Is it redox? No, there's no free elements. Compound, compound. Next step on my list, is it neutralization? No, right away, neither of them start with an H, so it can't be neutralization. Our default then is precipitation, our third one on the list. And here's what we're going to do. It's two steps just like yesterday. We're going to do an ion swap, so that's review. That's good news. But then we're going to label the products as either S or AQ, solid or aqueous. So first, let's do the ion swap, though. The first part of this compound is strontium. The first part of this compound is rubidium. I need them to switch places on the other side. When that happens, rubidium will now be with nitrate. So it'll be RbNO3. Stop me if I do anything you don't understand, please. Strontium, right here, Sr will no longer be with NO3. Sr came to there. So now it's SrCO3. You'll notice as far as subscripts go, that the 3 did come along with NO3 because nitrate's polyatomic, but the 2 did not. CO3 did go immediately to the other side because carbonate is polyatomic, but Rb2 is not. You've got to get used to which subscripts move. Any questions so far? Again, just like yesterday, we built compounds. Anytime you write down your own little compound that didn't exist from something I gave you, you've always got to check the charges. Always. So you should have a periodic table in front of you, but again, stop me if this doesn't add up. Rubidium is in group 1. There's a +1 above him. Nitrate is on your polyatomic list. There's a -1 assigned to him there. If they're both 1s, nothing happens, so we got lucky. Strontium on your periodic table is in group 2. There's a +2 written above him. Carbonate on your polyatomic list has a -2 assigned to him. Again, they're both 2s, so it's nice when this happens. We don't have to go and change anything. It turns out it was correct on our first go through. Now for the new thing. We did an ion swap. All right, here we go. Perfect. That's exactly what will happen if I mix these two things together. The question is, which one of those is the precipitate? Which one is solid? Look at your new friend. You'll notice that your new table here is broken up into two sections. This top section tells you all of your aqueous compounds. Very straightforward. The bottom section tells you all of your solid compounds. Again, very straightforward. But here's the deal. Look here. Look at me. All these elements listed up here are usually aqueous. They're almost always aqueous if one of these things is a part of the compound. Same with down here. If one of these guys is a part of the compound, that compound is almost always solid. But what is this other column over here called? What is the column called? Exceptions. What's it mean if something's an exception? It means that, yeah, it means it's the opposite, all right? Like if I said all of y'all are cool except for Roman, then we all know right away that he's just not the guy that we like. Sorry, I love Roman to death. It would make it go the other direction, all right? So let me show you how this works. Look at this guy here. The way that you're going to identify your compounds is by looking at that second part. Find nitrate on your list. Find NO3 somewhere, anywhere on the paper. Is NO3 connected to the AQ or the S section? There he is. He's right here. He's the third one down. This compound is usually aqueous. He's on the aqueous list. But go and check the exceptions. Because if one of the exceptions applies, well, then he's going to be the other one. What are some of nitrate's exceptions? None. It says that there are none. This compound is aqueous. Let's check the other compound. Again, it's the second part of the compound we're going to look at. You see the CO3 there? Carbonate? Find him. CO3 is somewhere on this list. Find him, find him, find him. Is CO3 usually aqueous or solid? Yeah, he's down here. All right, he's the very first compound on the solid list. So he's usually an S, but he does have exceptions. Let's see. He's solid unless he's bonded to ammonium. That's not ammonium, so we're good. Or an alkali metal. This is going to take some review. Where are the alkali metals? Which family are the alkali metals? The first column. Hydrogen's column are the alkali metals. So understand what the exception says. It says that this compound will be solid unless it's bonded to NH4, which it's not, or if it's bonded to any element in that first column. Is strontium in that first column? No. So the exception doesn't apply. We have found our precipitate, and we're done. We did an ion swap, and then we identified the products as either solid or aqueous. Let's do another one. Example 2. Hey, look at this 4 right there. Is that 4 going to automatically go to the other side? Yes, he will. How do I know that? Because CrO4 is a polyatomic ion. So right away, I'm just going to write it. CrO4. He ain't going nowhere. What about that 4? Does that 4 get to go to the other side automatically? He also does. Because ammonium, NH4, is on that list. And those are the subscripts that we know stay no matter what. Now, he's going to be swapped over, so I can't just write him yet. But iodine's not going anywhere. All right, so the second part of each compound will stay. But the PB and the NH4 will switch positions. So NH4 is going to come over here to the front guy. NH4. And PB is going to come over there to the second guy, PB. And now we've done our ion swap. But we built compounds. Don't skip the part where you check charges. And the lead here is actually really tricky, so pay attention because this is kind of a messed up one for an example. I need to use a different one for my examples. What's ammonium's charge? It's a 1. What is chromate's charge? It's a 2. The numbers are different this time. My 1 will cross there and nothing will happen. My 2 will cross there. All right, and that will happen. NH4 in parentheses with a 2 outside of it. All right, here's my sneaky lead. In order to know lead's charge, you'd have to know lead's charge over here because it'll be the same on both sides. But lead's charge over here is deceiving. Anybody know what it is? It's a 2. The only reason I know it's a 2 is because chromate's always a 2. So the only reason that there wouldn't have been a crisscross is if they were the same number. Again, I'm sorry. But yeah, it's got to be a 2, not a 4. All right. If there was a 4, there'd be parentheses on another 4. So yeah, lead is 2. What's iodine? It's 1 based on your periodic table. The numbers are different, so crisscross them. Any questions? All right, so there's our products, but it's a precipitation reaction, and I must always check the solubilities of a precipitation reaction, S or AQ. So let's go to our list. Check it out. Let's do my first product. I'm going to concentrate on the CrO4. Find chromate somewhere on the paper. You find him? He's the 3rd item on the 2nd list. He's usually an S, it says. Let's look at his exceptions. Unless he's bonded to ammonium. Is he bonded to ammonium here? He is. He is. There he is. Chromate, it said, was usually an S unless he's bonded to ammonium. And if the exception comes into play, you just assign it the other letter. Okay, well, even though he's usually S, this compound is aqueous because an exception pushed us to the other option. Let's do the solubility of the second compound. It ends in iodine. Find iodine somewhere on that paper. Did you find him? Iodine is the second to the last item on the first list. It says that iodine is usually aqueous. Don't write that. I haven't checked the exceptions yet. But it's usually aqueous. Let's look at his exceptions. Unless he's bonded to silver, lead, or mercury. Is he bonded to one of those exceptions? Lead is an exception. So let's push him the other way. There's my precipitate. Lead 2 iodide is the precipitate of this reaction. What do y'all think of this? They're working on both of these examples, so write them down, pause the video, see how far you can get. On my first problem, my ion swap will take place between aluminum and sodium. They're just going to switch places. When I do that, I want sodium to be with PO4. and I want aluminum to be with SO4. I built new compounds, so I must check charges. Sodium is +1 and phosphate is -3. Crisscross, 1 to phosphate, nothing happens. 3 to sodium, that happens. Aluminum is +3, sulfate's -2. The numbers are different, so I'll crisscross. My 2 will come here to aluminum, my 3 will go to sulfate, and it looks like that. Check solubilities. If I find phosphate on my list, he's located on the S. Phosphate is usually solid, unless he's bonded to ammonium or an alkali metal. Sodium is an alkali metal. He's in that first column, which means the exception happens. When the exception happens, instead of picking the S like it normally would, I just pick the other guy. This will be an aqueous solution. Check the solubility of the other product. I look for sulfate. Sulfate is located at the very bottom of the aqueous list, but he's got exceptions. Strontium, barium, lead, mercury. Aluminum is not one of his exceptions, so he will stay aqueous. Who sees it? What's the next thing I'm going to say? No reaction. Remember, a precipitation reaction must form a solid, or it won't have even happened in the first place. Since my prediction states that both of these products would be aqueous, that means that they never would have formed in the first place. If I mix aluminum phosphate and sodium sulfate together, nothing happens. They just float with each other. Two aqueous products equal a no reaction. We symbolize a no reaction just with a NR. Let's do this bottom guy. Here, I want my ion swap to be between silver and francium. So francium will be with my chlorate, FrClO3. Silver will be with my bromine, AgBr. Again, we built new compounds, but this one's kind of nice because it's +1, -1, +1, -1, if you checked the charges. So there will be no crisscross of anything. ClO3 is on the top list as aqueous, and he's got no exceptions. So right away, we've got an aqueous product. Bromine is also on the aqueous, but he does have exceptions. Silver, lead, mercury. Silver is an exception, so instead of being aqueous, we'll give him the other label. We found our precipitate, and we're done. Short periods tomorrow, computer day. Have a good one.